Good morning. Again, for those of you who were here earlier, we started once, now we're starting again. No one was here. We just got so excited. We began and I looked at the screen and there was nobody in chat. So, welcome. If you can throw some green check marks in there so I can make sure we're all together. A couple things while you guys are doing that. I see that a few people are asking questions about the midterm. And a few people are asking questions about mark cutoff and grades and things like that. So let's get those out of the way first and then we'll jump into Unit 4. And I know Taylor is mentioning that there was no lesson, so I'll explain that as well. Okay, so let's start with some of the things that people were mentioning here. So first thing is the midterm is November 9th. I believe it's a Monday. Maybe you guys have a calendar. You can look at that and confirm that for me. So November 9th is the midterm. It's going to be at Central Gym. It'll just be you guys, nobody else. Which leads to the second question that somebody, I think Abby and Ava or Avery were questioning, well, if our marks get cut off on the 6th and our the midterm exams on the 9th, how does that work? So this is how it's gonna work. Basically, when we're kind of working our way through the course, we'll probably get done another 4 lessons, so in Unit 4, and there might be a quiz or something from Unit 4 that goes on your marks. But wherever we end up on the 6th, that's kind of where our grades will be cut off. So I'm not gonna say, oh, we've almost made it through Unit 4 and you guys must write the Unit 4 test. No, if we don't get to the Unit 4 test before the 6th, then that's fine. We won't have the Unit 4 test on the report card. What we will, or I will do is, even though we have cut off marks on the 6th, the actual end of term isn't for an additional week. It just gives us time to get everything marked, get you guys kind of caught up in terms of late work if you if you're a little bit behind. And then once that all gets out of the way, we get everything in marks in and everything, all I'm gonna do is on the 9th, after you guys write the midterm, I'm gonna mark them all and then I'm gonna input that grade. So the interim will be on your first term report card, but the mark cutoff is more for the material in the course. Where did we kind of end up in the course? So I don't know if that makes sense or if that just confuses it a bit more, but that's kind of what we're gonna do with the midterm. So it is gonna go on your term 1 report card. The mark cutoff is more for just the things that we will encounter in the test. The midterm. How many questions on the midterm? I'm gonna spend a couple days next week. We'll have a bit of a review and go through some stuff. I decided to make the midterm, and you guys can do it by hand, multiple choice, and then a few written questions. I haven't decided how many questions, probably like maybe 40 questions, maybe 30 multiple choice, and about 10 sort of written, or maybe like 35 multiple choice and 5 written. I haven't sat down to make it yet, so I don't know what it's gonna look like yet. It's not a big thing. It's just, it's going to be units 1, 2, 3, and then a little bit of a unit 4. So it's nothing to be afraid of. Basically, you guys are writing your unit tests at home. So I don't know who's at home with you. Maybe your big brother's doing it for you. And, there's no way for me to figure out who's actually writing the test at home. I trust that you guys are doing it, and I know you guys are trustworthy and you're doing the work yourself. Don't get me wrong, I'm not accusing you of cheating, but I have no accountability sort of thing. So if you guys come in and write a midterm and then kind of like a final exam at the end of the semester, at least then I can say, well, I know the conditions under which these tests were written, so I can be confident in the sort of the validity of them. Just kind of a reality of taking a course, I guess. How much time will you guys have to write it? I'll be there all morning, so I'll budget probably the test should take maybe an hour to an hour and a half. Maybe an hour and a half, it's a few more questions than a regular sort of test, 20 that you guys have been doing. But I'll be there from 9 till like 12:30. So you guys definitely will not run out of time. I'll just, basically stay there until you're done sort of thing, but within reason. So I don't ever want time to be an issue with anything we do in the class. I know that little timer and some of those quizzes that I forget to take off is kind of like you just stare at it and it kind of eats away at you. A few things about the course. I put in some dates for Unit 3 work. You can see here, Unit 3 learning guide should be submitted by tomorrow. And then your Unit 3 test should be written either Friday or Saturday or Sunday. So you should get it done by Sunday at the latest. It kind of works nicely that Mrs. Ward is going to take both blocks tomorrow. So I'm not going to do anything new in math. And the lesson I do today is actually grade 9 math kind of review. So it's kind of a nice segue for you guys to get all of your old coursework tidied up. And then you don't have to worry about kind of mixing your units up. So far, we've been kind of finishing a unit, then starting the next one. This is kind of a nice sort of break before we start Unit 4. I'm only going to do one lesson today, and then it's just a review of grade 9 anyways. And I want you guys to kind of get everything caught up to kind of Unit 3, and then we can kind of worry about Unit 4. And Taylor had mentioned this before, and I think Jade said she's having issues with her printer. I apologize. Normally I get all of the lessons printed. Yeah, sorry, Taylor. I was talking about getting the Unit 3 test done. We finished Unit 3 yesterday, and we want to get Unit 3 out of the way, and then we'll kind of move into Unit 4 slowly instead of kind of plowing through it like we have been doing. Unit 4, I only had the one lesson completed. Basically, the lessons I have were a little bit different than the textbooks. Presentation of the material is a lot different than what's in the course here. So I had a lot of things to move around, and I might actually add a whole nother lesson in here. So I'm just kind of tweaking things. So I only included the one lesson, and hopefully by the end of the day on Friday, I'll have all of them grouped together again. I just want to go through them one more time and make sure I haven't missed anything. So I apologize for not having them all done ahead of time, but I figured we're only going to do this one lesson, and then you guys probably starting on Monday again will get to the rest of it. So I'll have the rest of the lessons uploaded for sure by the end of the day tomorrow. I just wanted to go through them again. So that's kind of housekeeping. We are done Unit 3. You should have your learning guide submitted by the end of the day tomorrow at the latest. You should have your test written anytime between now and Sunday night. So it gives you plenty of time, I feel, to get that Unit 3 test out of the way. And then we're just going to dip our toes into Unit 4 right now. And I don't foresee it being anything difficult today, just kind of stuff we've been doing, stuff you did in grade 9. So let's jump into this. Also, you should know that at the end of this, if you have any further questions about Unit 3, I'd be happy to go through those. But I just want to get this out of the way just so we're kind of keep moving. So here we go. This is Unit 4, Lesson 1. If you printed it, great. If you didn't, maybe just write down some of the questions we do. As I said at the beginning, it's basically a review of grade 9 stuff and some of the stuff that we've been doing. So let's see how it goes. All right, so Unit 4, Lesson 1, the prefix mono means what, and bi means what, and tri means what, and poly means. These are all terms, they're prefixes that go in front of lots of words kind of common in our language. Do you guys know what like mono or bi, tri, poly, you know what these mean? Think of things like a bicycle. Why is a bicycle called a bicycle? I'm obviously emphasizing the word bicycle at the front of that, but a bicycle, what does that mean? Tricycle, what's that? 2, 3, yeah, these make sense. Mono, maybe, I think mononucleosis, if you've been like, oh, my friend has mono. I think that's, I'm not a doctor, I've never had it before, but I'm pretty sure mono is like you have a lot of white blood cells mono meaning lots of white blood cells, just all your blood is that white blood. Bicycle is 2, tricycle is 3. How about poly? That one's a little tricky. Alex is going with 4 or more on that one. And Taylor, I got the mono thing right. I've never had it. I heard it's pretty terrible though. Here we go. So prefix mono means 1. You guys got that one. Bicycle means 2, or bi is 2. Tricycle is 3. Poly doesn't mean 4 or more. Poly means many. Now, there are prefixes for 4. There are prefixes for 5 and 6 and 7 and 9 and 10 and 11. They're just not as common. They're used a lot in science, in organic chemistry. We'll actually look at them once we start science next semester. But poly means many. If I said a polygon, that's a many-sided figure. If I say a polynomial, that's a term with many parts to it. So a monomial has 1 term, a binomial has 2 terms, a trinomial has 3 terms. And a polynomial, which is a word you'll see a lot even in the title to the lesson, polynomial just means many. We have some discussion going on mononucleosis. Again, I'm not a doctor. Maybe it was a bad example. Maybe the spleen is doing something with the white blood cells and gets swollen. I'm not sure. I think it's kind of beyond what we're talking about here. Oh well. Maybe somebody, Haley had mono. You can just, did you have a lot of one thing when you had mono? Maybe a lot of pain. Hey, Haley? All right, so we have a few examples to look at. So identify the following as a monomial, binomial, or trinomial. So a monomial has 1 sort of term in it. If it has 2 terms, it's a binomial. If it has 3 terms, it's a trinomial. And what do I mean by terms? I just mean how many things are there. So I have this 12x, and I have this minus 5. How many things do we have? How many terms do we have? That looks like 2. So if we have 2 terms, that is a binomial. The next one, we have this 2x squared, we have a 7x, and we have a 2. It doesn't matter if the terms have x's in them, if there's x squareds, or what there is. It's just how many things are there. So this one has 3, so this is a trinomial. Again, 78 minus z to the power of 6 and positive 2x. That's 3 things, so that is a trinomial. Now, these vocab things that we're going to deal with here, it's not like, I guess you might see some questions regarding them. Mainly just to be able to identify what you're dealing with and classifying and things like that. So that's kind of just a little bit of stuff to get out of the way. The second thing is maybe a new idea, the degree of a polynomial. Now, we don't really, it's not super important for Math 10, the degree of a polynomial. You might see a few questions regarding the degree of a polynomial, but it's something that it's kind of building the foundation. Once you get into grade 12 and you start calculus, or if you go to university and pursue math a little further, the degree of a polynomial becomes kind of important. But for now, it's just being able to identify it. And it's a really, really easy concept. Sometimes students have a difficult time with it. I'm not sure why, but I guess it's just remembering what it is. So in general, the degree of a polynomial is the term with the greatest exponent. Now, we're going to look at a couple examples, and then you'll probably kind of understand what I mean by degree. So identify the degree of the following polynomials. So we've just said the degree is the term with the greatest exponent. Okay, Damon, good luck with your re-login. The term with the greatest exponent. So I look at my terms. I have a binomial here. I have two terms. I have 12x and I have minus 5. I see that I have really no exponents to speak of. I don't have any exponents next to the 5 or the x or the 12. But what is there? Well, I know if there's nothing there, that just means there should be a 1. So this 12x to the power of 1, and this 1 is the greatest exponent I have. So this would be called a first degree polynomial. Now the degree doesn't have anything to do with how many terms there are in the polynomial. It's just what is the biggest exponent that's there. So if we look at example B here, I look at my exponents. I see that this first term has an exponent of 3. This one has an exponent of 1. What is the largest exponent there? Looks like it's a 3. So this would be a third degree polynomial. So it was perhaps a coincidence that there was 3 terms and the highest exponent or the greatest exponent was a 3. So technically speaking, it was a third degree polynomial or a third degree trinomial, because 3 terms is trinomial, kind of bringing the two ideas together. That's a good question, Alex. And polynomial, it just means many terms. So a polynomial is just a general term. Just like a polygon is a many-sided figure. If I talk about polygons, that means like a square. That's a polygon, it has 4 sides. A triangle, that's a polygon, it has 3 sides. So when I talk about polynomial, it's just a general term that means many. So I don't have to talk about the exact number that's there, just many terms. But you're right, it is technically a third degree trinomial. This last one, I look at my exponents, I see that my z has a power of 2. The 78 is just a 1, this z here is a 1. So my greatest exponent is this guy. So this is a second degree. And then kind of building on what Alex just said, I could say it's a second degree polynomial, or I could be specific and say, okay, this thing has how many terms? I have 1 term, I have 2 terms, I have 3 terms. So this is a second degree trinomial. So polynomial is just general, and trinomial is more specific. I kind of didn't want to mix the two ideas together to kind of avoid confusion, but Alex was 100% correct with his observation. So there you go. So those are maybe 2 new ideas that you probably haven't encountered before. The idea of, well, you probably in grade 9 knew maybe what a binomial or a trinomial was. You don't deal with a lot of them, but there you go. This third degree, second degree stuff, that's probably a new idea. Pretty straightforward idea, at least I think so. Maybe you'll agree or disagree with me. The next example is basic substitution. So we have a value for x and a value for y, and we need to substitute them in. Now, doing this sort of process becomes extremely important in this unit, because when we are doing questions, we can substitute values in for x and y, and we can figure out if we got the answer right or wrong. It's an easy check to do on our work. So here we go. This first example, 2x squared minus 3x plus 7. I believe I even included some of these in the review that I gave you right at the beginning of the year, just to kind of see where you guys are at. So it's telling me x is equal to 3. So everywhere there's an x, I'm going to substitute in a 3. So I'm going to go 2 times 3 squared minus 3 times 2 plus 7. So I've replaced all of the x's in my equation with 3's. At this point, we're going to follow our BEDMAS and we're going to do anything inside brackets. Do I have any brackets? Yes. Nothing to do inside of them. All right, I can move on to my exponents. I have 2. 3 squared is going to give me 9. Negative 3 times 2 plus 7. Perfect. Why is the second one a 2? Because I wrote it in as a 2 and that was incorrect. That's why. Thank you for catching that. All right, continuing on, 3 times 3 is 9, 2 times 9. So I've done my brackets, I've done my exponents. There's no division, so I guess I'm done that. Multiplication, so 2 and 9 gives me 18. 3 times 3 is 9. I have this negative 3 times positive 3, I guess, technically speaking. And then plus 7. So I did my brackets, exponents, division, multiplication. Now I'm on to addition and subtraction. So let's figure this out. I can just do this all in one step. 18 minus 9, it's going to give me 9, and then I'm going to add 7 to it. So I'm going to end up with 16. So hopefully you've seen this stuff before. I have a feeling you're pretty good at it. Most of you guys did really well with it in the review. I'm just gonna, go through these last two, and I have a feeling you guys could probably just do them without my help, but here goes. This one has a y in it and an x, so I'm gonna substitute the 3 in for any x's I see. The y is gonna be negative 2. There's no brackets to deal with, no exponents, so I'm right on to multiplication. 3 times 3 is 9 times 2, which is negative. It's going to be negative 18 plus 7 minus 3. Negative 18 plus 7 should give me negative 11 minus 3. So I should end up with negative 14. So hopefully that's okay. The next one here is 2 times x. So wherever there's an x, I put in a 3. This one is x to the power of 6. Apparently I wasn't thinking well when I did this example and created it. Minus 3 plus negative 2. This is going to be a pretty big number. Oh well. 3 to the power of 6. I don't have that memorized, so I'm going to have to plug her into my old calculator. So according to BEDMAS, I'm going to deal with my exponents. I have this 2. I'm just going to bring it down. 3 to the power of 6 gives me 729. 2 to the power of 4 should give me 16. And because it's negative 2 to the power of 4, there's 4 of them, so it's going to end up being positive 16. Minus 3. I'm going to combine this plus negative 2 here, and I'm just going to combine it to be minus 2, because a positive and negative together gives me a negative. So I'm just going to subtract 2. So I've done my brackets, or my exponents. Now I'm on my multiplication. So 2 times 729, it's going to give me 1458. Plus 16 minus 3 minus 2. At this point, I am just going to add 16, subtract 3, subtract 2, and I get 1,469. So that is just substituting values in for x and y, following my order of operations, and just determining a solution. So, stuff that you did in grade 9. I hope. Perhaps, maybe not. Maybe you didn't deal with exponents that were quite that big when you substituted in grade 9. I don't remember grade 9 math. I haven't taught it for about 8 years. Seems like a long time. The next one is combining like terms, which is something we've been doing a lot of already, which is kind of funny how the unit's laid out, because we've already been doing some of this stuff with radicals. Now we're going to do it with polynomials, binomials, trinomials, and maybe we probably should have switched the order of the lessons, so we kind of did this stuff first, which is a little bit simpler, but you guys are pros now, and we're going to go from there. So simplify and combine like terms. It's important to identify in this first question here that the operation we're dealing with the brackets here is we're just adding these two things together. So I have 4x plus 3x. How many x's do I have? Well, I have 4 plus 3 is 7 x's. And then I have -2 and -1 together gives me -3. So I just have 7x minus 3. When we look at the second one, this is maybe where this gets slightly tricky. I'm subtracting everything in the second bracket. So kind of the way I learned how to do this was that there's an imaginary -1 out front here, and it's being multiplied by everything inside the bracket. So I'm going to change the sign of everything in the second bracket. Is this something you have encountered before? The subtraction of these terms, kind of like what I'm doing right now. Is this something that you've seen, or is this kind of a new idea? You have to refresh my memory. I'm going to just rewrite it. 4y minus 7. The -1 times 2y is going to be -2y, and -1 times +1 gives me -1. So I'm just going to combine my like terms, simplifying. I have 4 y's, I have 2 y's, I have a 7, I have a -1. So 4y minus 2y is 2y, -7 minus 1 is a -8. There's a different way to do that. So you have seen it before, but you just learned it kind of a different way. This is the way I'm going to deal with these things. When I have a negative out front, I'm just going to change the signs in here. So I'm going to go negative and negative together gives me a positive. My 10x is now -10x, and my positive and positive, sorry, negative and negative again gives me a positive. Fixing all those signs, combine like terms. I have an x squared, I have an x squared, I have an x, I have an x, and then I have just my constants, my 3 and my 1. So I have 4x squared plus another 1 is 5x squared. -2x minus 10 is -12x. And then 3 and 1 gives me a +4. Now, strategically, I've written the answer in descending order of exponents. So I don't know if that makes sense, but I have my x squared term first, then my x term, and then just whatever's left. It's just kind of how things will be written. It's just one of these kind of unwritten math rules when we write down our polynomials, in this case a trinomial. We always start with the biggest exponent, and then go to the second biggest, and then go to anything without an exponent. So that's simplifying, collecting like terms. Does anybody have any questions there? Disliked how I did that? Example? Everything's kind of peachy. We're doing okay. Be negative 11. Is there a different way to do that? Would it be negative 11 because you add the negative 1? This is 10 x's. I think this is what you're referring to here, Taylor. And this is just a 1. So these are different things. Kind of like when we talk about combining like terms. You don't want to combine your apples and your horses together. They're different. The x's and the 1 is completely different things. So we don't want to combine those together. So when I'm combining the 1, I'm combining it with the 3 because those are the same. This 10 is get combined with this 2x because those are the same. So combine my x's, I combine my constants. That's where the 4 came from, and that's where the negative 12 came from. The imaginary negative 1. It's multiplication up here because this is a 1 and the bracket would be like 1 times everything inside the bracket. So I'm multiplying that 1 through, not adding it. If that makes any sense. Just 2 more examples, and this is all stuff that we have been doing. It's kind of weird to see it again, but I guess this is the why. Why are we doing this stuff? To kind of build on the things we're doing in this unit. So when I kind of purposefully just picked really hard ones for this. Not really hard. There's really basic ones in the learning guide that you guys will look at, but these ones are just the more challenging ones. I didn't feel like the basic ones were really necessary to go through again because you guys have seen this stuff in Math 9 already. So when I am multiplying my terms, I multiply the constants, and then when I multiply with my exponents, it's important that I add. So what's going on here? I guess I could do this in 2 steps, or I could do it in 1 step. I could go 2 times 3 times the negative 4, or I could just deal with the first 2 and leave the second or the third one by itself, and then once I combine these 2, I could then just bring this negative 4x3y squared down and then multiply these together now. I'm kind of just tempted to do it all in one big step. If you don't like it, then you can speak up. I'm going to go 2 times 3 times the negative 4. So 2 times 3 is 6 times negative 4 is negative 24. Then I'm going to take all my x's. So in this case, I have x squared, x to the 1, and x to the 3. And what I'm going to do is maybe I'll show an additional step that I probably normally wouldn't show. I'd go x to the power of 2 plus 1 plus 3. And then I have my y's. I have 2 y's here and another 2. So I have y to the 2 plus 2. So the negative 24 is just going to come along for the ride. X to the 2 plus 1 is 3, plus 3 is 6, and y to the 2 plus 2 is 4. Now, typically I probably wouldn't show this kind of middle step. I would just jump right to the answer. I guess just kind of depends on how comfortable you are with these things. Alex is asking, can we go over the last question of the learning guide on page 10? Yeah, I'll definitely have time for that, Alex. If I forget, remind me, but I don't think I will. Only got one more question to get through here. This one's kind of nice because there's not even any negative exponents to deal with. It's just positive ones. So what I'm going to do is what I've been doing. I'm just going to cancel things out. If I have 4 x's on the top and 5 on the bottom, well, all my x's on the top are going to go away. I'm going to be left with 1 on the bottom. 7 and 14. So I know 7 goes into 7 1 time, and 7 goes into 14 2 times. I see that I have 3 x's on the top and 4 on the bottom, so that 4 is going to change to a 1. I have 7 y's on the top and 5 on the bottom, so I'm going to be left with 2 there, and then 2 z's on the top and 1 on the bottom. It's going to leave me with a 1. Now, I like doing it this way. I know people don't. It's kind of your preference. So I have this 1, so I'm not even going to write it. I got rid of all my x's. There's 1 left on the bottom. So what do I have? The first thing I see here is I have a y to the power of 2 left on the top. And then I have a z to the power of 1, or just z. On the bottom, I have this negative 2. I have an x to the power of 1. And that's it. Oops. I don't like how that looks. I'm going to go y squared z negative 2x. And that's kind of just where I end up there. So we've done a ton of questions like that already, and you guys have been doing well with them. So they, if anything, are going to get easier in this unit 4 most of the time. Taylor, I see you had a question about the previous one, 2 plus 2 plus 3 instead of 2 plus 1 plus 3. So the 1 is coming from the x here, has no exponent. So if it has no exponent, I'm just going to leave it as a 1. So there's the 2, there's the 1, and there's the 3. 2 plus 1 plus 3 gives me the 6. So if there's nothing there, it's a 1. If I had a 2 there, it would have been 2 and 2 and 3, but there wasn't a 2. Do you divide each one the number? Yeah, I guess you could. In this case, you have the 7 and the 14. And if I just had 7 over 14, that's just going to be the same thing as 1 over negative 2, which is what I really have out front here, but I don't write the 1. All right. That's it for this lesson. I do have a bunch of time left. I figured I would. I just kind of slowly easing our way into here. So I just want to mention the learning guide for this unit. And then if you have any questions, which a few of you have already put into chat, which is great, from the last unit, I'd be happy to go through those as well. So the learning guide for unit 4, polynomials. I don't expect you guys to kind of power through this right now, but the first question here, the polynomial stuff, a monomial with 2 variables, trinomial. When we talk about variables, that's like an x and a y. Those are 2 variables. Trinomial includes a negative sign. Polynomial, 4 terms. So again, poly is many. 4 terms, 3 different variables. Variables could have like x, y, z, a, b, c, whatever you want. So that's kind of how that number 1's working for us. Number 2, rewrite the following in descending order. So you want to go from descending order. It's kind of explanatory, but greatest exponent to smallest. So if I see I have, what's the greatest one here? I have a 7, then I have a 6, then I have a 5, then I have a 2. So just looking at the exponents there. Evaluate the following for number 3. That's pretty self-explanatory, just substituting and calculating. Might run out of room, maybe not. Write 3 different terms that are like. So similar to. 4 shouldn't be terribly difficult. Adding, subtracting polynomials. So simplifying, this is just combining like terms. So that's that. Pretty straightforward. Multiplying, dividing. I didn't do any distributive ones. I think this actually comes up in the next section. So for day 1, we're going to end it there, right before multiplying and dividing polynomials on page 2. So not a ton of stuff. And the next time we meet again is going to be Monday's class. And we have a lot of time between now and then. So there you go. So questions from the learning guide from the last unit. I can see there's a few of them. I'll just start at the top, and on page 10, last question of the learning guide for unit 3. I had a feeling this would be a question. British researcher developed a formula to determine walking or running speed based on hip height and stride length. So S is 0.78 L, 1.67, blah, blah, blah. S is the speed in meters per second, L is the stride length in meters, and H is the individual's hip height in meters. So when it says the hip height, which is H, is 0.93 meters, and their stride length, they're including that as L, is 1.25 meters. This is kind of a substitution type question in which we will have to use the formula to figure out the speed. So speed is 0.78 times L, 0.78 L to the 1.67 and H to the 1.17. So just rewriting the formula. So I'm going to substitute. Anywhere there's an H, I'm going to put in this 0.93, so that's going to be on the bottom. And anywhere there's an L, I'm going to put in the 1.25 right there. So again, I'm going to rewrite it 0.78, then I have L, 1.25 to the power of 1.67. And then I have H, which is 0.93 to the power of 1.17. At this point, we're going to just do our order of operations. Do I have anything to do inside my brackets? No, I have my exponents next. So if we are dealing with our exponents, first thing we have to do on the top is this 1.25 to this exponent 1.67. So there's no kind of easy way to do that without a calculator, and I think I warned you about the calculator thing at the very beginning. So let's just jump over to my calculator here, and I'll just plug it in. I'll show you what that's going to look like. So if I have 1.25 to the exponent 1.67, so I have 1.25 to the exponent 1.67. That's 1.25 x to the y, 1.67. Just going to give me a decimal. So I'm going to rewrite this 0.78. And the 1.25 to that exponent is 1.45157. And that just goes on. I'll try to keep that little number in the window of my calculator. On the bottom, I'm going to end up doing the same thing. In order to kind of get as close to the answer without rounding as possible, what I'm going to do is I'm just going to do the top right away. So in my calculator window, I already have this number. And I know from looking at the question, I'm going to multiply it by 0.78. So I'm just going to hit multiply, 0.78, and equals is 1.132222, whatever. So I know the top is going to be 1.13222222. Now I'm going to deal with the bottom, 0.93 to this 1.17. So I'm going to go 0.93 x to the y, 1.17. The bottom's going to be 0.91859. And that's going to continue on. Hopefully I've included enough decimal points. Just going to do the basic division here. 1.1322. I have a fancy button on my calculator that I like a lot, and it's the answer button. So whatever answer I previously had, I can hit second, or this one, sorry, it's not second, it's alpha, and then equals, and it brings the answer that I previously had in there, which is going to make sure that I have as many decimal places as possible. So 1.23 meters per second would be the answer. And I only know it's meters per second because it said in the question. You're going to end up with an answer in meters per second. Hopefully that helps you, Alex. That one was definitely a battle with your calculator. If you kind of have sort of confidence in how to do the calculations, you'd probably be okay. But if you're kind of haven't figured out your calculator yet, that would be a really difficult question. I'm going to go back to chat. So that was the last one on page 10. 8A on page 9. Let's go to 8A on page 9. All right. Leave that up for a second in case anybody is interested in it. Although just looking at all of this probably doesn't make a ton of sense right now. But I guess you could always go back and look at the video and see my solution there. You're having issues with that one? This says write in exponential form. So I want to combine my root here into an exponent. So I'm going to take this 4a, which is still 4a. There's no exponent behind the 4 or the a or outside of my bracket here. So everything in terms of my power is just going to be a 1. And then I have this negative 3. As my root, or the index as we referred to it last day. I kind of have a sneaking suspicion that the answer probably doesn't have a negative exponent in it. So you would have to, at this point, say, okay, my exponent is negative. I had this negative 3 here. I'm going to have to flip it to make it positive. So I don't flip the exponent. The exponent stays the same. It's going to be 1 over 3. But I do flip whatever the exponent was acting on. So this is going to be 1 over 4a to the 1/3. So that might be where the trouble was coming from in that one. Getting all confused with the question requests here. So hopefully that one helped. Can you do number 8 on page 9? Number 8, page 9 of the learning guide. Number 8C on page 9. 8A, 8C. And then Haley, you've said you do number 9 on page 9 and number 1 on page 10. You don't need to do 8A anymore. Okay. I'm going to jump to number 9 on page 9, if that helps. Hope. Number 9. Convert the exponents, then simplify and write the answer as a radical. This is kind of a bit of a tricky question. This goes back to the flower. This is the power roots, the root little rhyme that I mentioned. So flower is the power. I have a power of 2, so that's the power. And then the root is the 3, or my index out front. I'm multiplying this by flower is the power, so the 3 is my power, and then my index is 4, my root is 4. I know I need to add my exponents, So I need to have a common denominator. Common denominator between 3 and 4 is going to be 12. So this is 8 over 12 and a to the 9 over 12. Probably can't read that. And then I'm going to add them together. So I'm going to get a to the 8 and 9, 17 over 12. I'll just keep working this way. Then it says write it as a radical. So I'm going backwards, kind of back to where I started here in terms of radicals, but I've now combined these two things together. So I go back to the idea of flour is my power. So this was a as my base. My power is 17, and the root was 12. So I put it out front. That's good. Maybe I'll do B as well. What do we think? Let's do B. Looks tricky. So what I'm going to do is I'm just going to leave this power of 1/2 out here for now. And I'm just going to deal with everything inside of it. So I'm going to rewrite it like this. So I'm going to go with my A. My A had a power of 3, and the root was 4. And the B had a power of 5, and the root was 4. So just dealing with things in the brackets. Now I go to my basic exponent laws. If I have an exponent outside of the bracket, I have to multiply it by everything inside of the bracket. So I'm going to go a to the 3 over 4 times 1 over 2 is 3 over 8. And b, the 5 over 4 times 1 over 2 is 5 over 8. Now I'm going to rewrite this. There's probably a few ways you could rewrite it. I know I have the 8th root for both of these things. I'll write it like this: a to the 3 and b to the 5. Because my power was 3, my power is 5, so they stick around, and then my root for both these things is 8. I could have written it as the 8th root of a to the 3 times the 8th root of b to the 5. That would have been fine as well, same thing. It's kind of nice to put them under the one radical sign so they're cozy, they have a friend to spend time with under there. So that was number 9, A and B. Wait, number 9 and number 1 on page 10. Don't need to do 8. Can you do 2 on page 10? So 1 and 2 on page 10, and then maybe we'll call her a day. This is page 10. Here's number 1, and here's number 2. All right, so find a number for x that makes the statement true. It's kind of a little bit of problem solving, I guess. I see that I have an answer of 25, and I see my base is 5. So if I just said 5 to the power of what gives you 25, you would say, oh, well, it looks like that's just going to be 5 to the power of 2 is 25. The problem with this question is a lot of times in math, we can give you a process to follow, and it kind of works all of the time. This one requires you to use a little bit of your brain. There's probably some sort of process we could follow every time, and it would work out. So I know that whatever's my exponent on my 5 needs to be a 2, because that 5 times 5 is going to give me 25. So right now I have this 3x plus 5. And I need to put something in there so this equals 2. because I know I want to end up with an answer of 25. Now I can just solve by inspection, just looking at it and think like, 3 times negative 1 is going to give me negative 3 plus 5 is 2. Or I could solve it mathematically. So I could say, okay, I'm going to subtract 5 from both sides. And I'm going to get 3x. That's going to go away. 2 minus 5 is negative 3. I'm going to divide both sides by 3. X is negative 1. So that's one of the way I can do these problems. And Alex, exactly what I was just saying. You are solving by inspection. That's what we call that. You're just looking at it and say, okay, well, it's 25. I know 25 is 5 squared. Whatever that exponent was has to be 2. So if I put in a negative 1, that gives me 2 in the top. So that's a perfect way to do it. There's nothing wrong with that. The next one here, I know I have a 3 as a base, and it's got to equal 27. So 3 times 3 is 9, times 3 is 27. So whatever I'm dealing with here, it's going to have to equal 3, because I'm going to need a 3 to the power of 3 to give me 27. So I can do the same process again. I can go 3x minus 6 has to equal 3, because I need 3 to the power of 3. And then I can add 6 to both sides. 6 and 3 is 9. Divide both sides by 3. And I can get 3. Or I can solve by inspection. I can say, okay, well, I need to get a 3. 3 times 3 is 9, minus 6 gives me 3. So that's number 1. I think the last one was number 2. If a cube had a volume of, if a cube has a volume of 3,375 cubic centimeters, how would you write the length of one side as a power? So I know if I have a cube, here's my cube, I'm going to have length times width times height, and they're all going to be the same. So the volume of a cube is length times width times height. These are all the same. So maybe I'll just write it as length times length, which is just length cubed. That's why it's called a cube. So the volume of a cube is just length cubed. Hopefully that makes sense. Now it tells me the volume is that, so I'm just going to plug that in. Now this is a lot of work you probably don't need to show for this question, but 3,375 is equal to the length cubed. Now, if I want to find just the length, the opposite of cubing something is taking the cube root of something. So what's going to end up happening here is I'm going to have the cube root of 3,375, which is equal to L instead of L cubed. And then it wants me to write it as a power. So I have no exponent. I have an index of 3 or a root of 3. So I'm going to have 3,375 to the 1 over 3 is equal to the length of the side. So maybe a bunch of work that you probably don't need to show to end up there. We've done a bunch of questions like that. I know you've encountered those before, at least with a square in grade 9. So that's something we definitely have seen before. I'm thinking I'm going to quit there, not quit, end. Don't want to be a quitter. Does anybody have any further questions before we kind of log out here for the day? Just when people are kind of typing. We're done Unit 3. You should get the test done by Sunday and get the review in so I can get you the... Sure. Mr. Ross, can we throw that question back up while I'm talking? Belle didn't get a chance to copy it down. Thank you. So again, you have your test on Unit 3 to do. Some of you still have a test on Unit 1 to do, which is a bit of a problem, but that's neither here nor there. We I've just done this Unit 4 stuff. We just started it, so things that you've definitely seen before. And if you didn't even do anything on Unit 4 until Monday, that would be great. That's kind of it for that stuff. I just needed to keep moving with Unit 4. So anyways, I'm sure that's probably good for that question for you, Bill. Jade, thank you for sending me that. I will have a read of it once I'm done here for the day. So if you guys need any help, have questions, let me know. You guys are going to do some English right now. Mrs. Ward is away. She's in a meeting. So you have Mrs. Wyatt. And Mrs. Wyatt is going to do the English all in Blackboard. So you're not going to have the live stream up. You're going to do everything in Blackboard with Mrs. Wyatt. And you're going to do that at probably, we actually, believe it or not, in our little building, we have a fire drill today. We have to do them. So I'm going to go ahead and say you're going to probably start that at 10:30 today because our fire drill is at 10:20. So you have a bit of a break now. And yeah, I won't see you guys tomorrow because you have full English tomorrow. So I'll see you again on Monday. So if you have anything that comes up between now and Monday, send me a message in Moodle and we can deal with it. So hopefully you guys have a great weekend, and we'll see you again on Monday or Friday. What are we doing? Fencing. I don't know if I'm coming. You should go fencing. It'll be awesome. So yeah, have a good weekend. We'll see you later.